In this problem, we are given continuously compounded rates from the market, wherever that may be, and we're trying to compute the continuously compounded forward rate between 2 days. So we are given the 188-day continuously compounded rate is 4.33, and the 312-day continuously compounded rate is 4.93. Okay, so there are a couple of ways to do this formula. There's a pretty quick way to do this because all of the rates are continuously compounded. We have a shortcut. I'm going to show you the shortcut first, but then I'm going to take you through a slightly longer version, but in my view, a little bit easier because once you've conceptualized what's going on in the slightly longer version, then it doesn't matter how the rates are given to you, and it doesn't matter what rate you're trying to compute in the end. So this first solution, which is quick, only works for continuously compounded rates. So there is a formula, so we can just solve here. So I'm going to use Excel to solve this problem because it's a little easier. For me, I use Excel as a calculator pretty much always, so this is what we're going to use. Okay, so there's a formula which goes that the forward rate between time 1 and time 2, we'll call that R12, is equal to, and in the numerator, it's R2T2 minus R1T1, all divided by T2 minus T1. So let's just see how that works. That's going to be R2, 4.93, times T2, 312 days. And again, here, normally we would think about time in years. Here, it doesn't really matter as long as we're consistent. Minus R1 times T1, divided by T2 minus T1. Let's just format that as a date. There we go. 5.8397. So that's our calculation. So pretty quick and easy. I like my cells to be formatted nicely. So we're going to do this in a different way, which is going to take a little more work. But again, in my view, it's a little easier to conceptualize. Okay, so what we're going to do is we're going to use discount factors. We're going to take rates, we're going to convert them into discount factors. We're going to take the ratio of the two discount factors to find the forward discount factor, and then we're going to invert that first formula we used to calculate the rate again. And like I said, that's going to work always, no matter how the rates are given to us. So this first formula that we did, the 5.8397, only works if the rates we're given are continuously compounded and the rate we want is continuously compounded. Okay, so I'm going to calculate the discount factors up here. So discount factor is the present value of $1. With continuously compounded rates, that's going to be given by e to the minus RT. T here is in years. So EXP is e to the minus the rate times time divided by 365. There's the first discount factor. And there's the second discount factor. Okay, so let's just look at that. That's just, again, e to the minus R2, 4.93%, times T2, which is 312 divided by 365. Now the forward discount factor is the ratio, and it's DF2 divided by DF1. So forward discount factor is the second discount factor divided by the first. Okay, so that's my forward discount factor. Oops, wrong one. Cell styles. Let's format these as heading 2. These two are calculations because we like to see them, but we don't necessarily need to figure out what's going on. We've just done discount factor calculations. We've calculated a forward discount factor. Now we want to find a rate, the forward rate, from the forward discount factors. Now we know the discount factor is e to the minus RT. To find the rate, we have to take the natural log and do a little bit of work, and we get this is equal to negative natural log of the discount factor times 365 divided by the number of days. Now this rate is valid between 188 and 312 days, so we have to do 312 minus 188. So again, this is just inverting that formula. We know the discount factor is equal to e to the minus rt. We invert, we find the rate is negative natural log of the discount factor times 365 divided by days. Days here are the days in our period. And hopefully, if we've done this correctly, it looks like we have, we get exactly the same answer. So for continuously compounded rates, we have continuously compounded rates. We want to find continuously compounded rates. Both of these strategies work. The first strategy was R2T2 minus R1T1 divided by T2 minus T1. That gives us the continuously compounded rate. The second strategy worked with discount factors. Take rates, find the discount factors, find the forward discount factors using a ratio, and then invert that discount factor formula to find the rate. I hope that was helpful.